Next, we have Ben Winger from the University of Michigan Museum of Zoology discussing maximizing the scientific utility of museum specimens from collision monitoring. Welcome aboard, Ben.
Hi, thanks, Heidi. Good to see you.
You too.
Thanks for having me. Let's see, make sure the slides are queued up here. Cool. All right. Yeah, this has been a great day, learning from everybody. I'm going to talk a little bit about an aspect that I'm sure some of you are familiar with, but maybe others less so, which is sort of, well, what happens with these dead birds after they end up at a museum, why do that in the first place, and how to kind of manage the relationships between collision monitors and museums. So, of course, we're all here to prevent collisions and reduce them, but they're happening. And so, part of what I'm going to be talking about is, given this mortality that's happening, how can we learn something else from it? How can we benefit from these dead birds while working to prevent them from for these collisions from happening in the future? And just to tell you where I'm coming from this, I'm an academic ornithologist, so I'm a professor at the University of Michigan. I do a lot of research on bird ecology, evolution, basic biology. I teach ornithology. And some of my research actually involves using data from collision specimens, which I'll talk about in a little bit. I'm also curator of birds at a pretty large research museum here at University of Michigan, and so we receive a lot of birds from the community. So I'm familiar with that side of kind of what it takes to uh, handle this sort of influx of dead birds. And then also locally, I'm active in the sort of local bird collision monitoring and prevention, both at University of Michigan, as well as trying to use our research to raise awareness nationally. Sorry, my Zoom is not very responsive. Okay, so first of all, what are these museum collections that I'm talking about? Well, this is kind of the behind the scenes of a lot of the large natural history museums. So I'm not talking about the display cases as part of the exhibits, but the drawers of specimens, not only of birds, but of other animals and plants. We call these herbaria. And often these large collections are associated with a large public museum. But sometimes they're at research universities, and they vary quite a bit in size. And quite a lag. So the kinds of specimens that these kinds of natural history museums can, or natural history collections can curate, are quite variable. So of course we have the bird skins and the round skin posts here, and more we can collect lots of different kinds of data from this. So we can get um, data on the pathogens and parasites that come in with the birds to try and understand their health. Sometimes we can only prepare a skeleton, which facilitates different research. But with technology like CT scanners, we can actually image birds and image other specimens in really high resolution in ways that weren't possible before. And then when we get birds in nowadays, we're not only saving the skin or the skeleton, we're also saving tissue samples that are useful for a variety of genetic work as well as research on pathogens. Okay, so why do this? These collections are really essential resources for studying ecology, evolution, conservation. And this is just an incredibly unique record of life on our planet, and it's really for posterity. So, as curator here at Michigan, I know that every week we have different scientists and researchers in our doors looking at the birds for all kinds of practices. So, if you've ever opened a field guide to birds, which I'm sure most of you have, a lot of the paintings there and the sort of basic species definitions are based on studies of specimens, but also basic biology of birds. There are so many uses of these specimens, and the uses are always growing and they're used in ways that we can't even imagine today. Okay, so it's important to know that so a little bit of terminology here. So when we talk about specimens from incidental mortality, this is what in the museum world we call salvage specimens. Okay, and apologize, there's like a 5-second lag between when I advance the slide and it advances. So this is the dominant source of specimen material in museums nowadays. Okay, so as 100 years ago, this was not the case. Most of the older specimens were actively collected, but as this practice decreases and our built environment causes so much mortality in birds, now by far majority of specimens that come into museums are from collisions with buildings or cars or communication towers or other industry. Okay, so if museums already have so many specimens, I mean, at Michigan, we have a couple 100,000. At the American Museum of Natural History in New York, it's almost 1 million specimens. So if we already have thousands and thousands of white-throated sparrows, why keep adding them? Why go through this trouble when it is expensive and time-consuming to keep adding specimens and curating them? There's lots of reasons for that, but what I want to highlight here is global change biology, which is trying to understand how and why our world is changing due to human impacts. And with collections, we can usually go back a century or more to look at human impacts. But of course, global change is happening now, and what happens today quickly becomes the past. And so, by documenting these bird collisions and curating them as specimens today, we're leaving a record for posterity to understand what has happened in the world. And so, with this, we can look at changes in avian biology. We can even use these physical specimens in ways you might not imagine. So they have records of the chemical environments that the birds were in, what they were eating. We can look at changes in timing of migration based on these records, so the phenology of migration. And we can even get genetic data from specimens, not only from today, but from these very old specimens. So as we build up these collections from salvage, we're accumulating a record that we can study with as time series. Okay, so I'm just going to give a couple examples of what kind of scientific research can be done. And these are from my own research and with collaborators, and these are just a couple examples of the various uses. Okay, so this actually goes back to Field Museum in Chicago. So this is where I did graduate school and started seeing all the birds coming in from the Chicago bird collision monitors from all over the city, as well as McCormick Place, which people have talked about quite a bit. And of course, Chicago is, as has been mentioned, unfortunately, there's a ton of bird mortality from collisions from all over the city. And over 40 years of Dave Willard and other collection staff working there, they've accumulated just a truly staggering number of specimens, including 40,000 specimens from McCormick Place alone. And so the really sort of widely known event at McCormick Place in 2023, this actually, although that was a massive increase in collisions for one night, this has been happening for quite a long time. And what's kind of incredible about the work there at the Field Museum is that they really did as best as they could to keep up with this influx of dead birds, which requires a tremendous amount of personnel time, both staff and volunteer efforts, to prepare these specimens as skins or skeletons, manage the data, and curate them in the collections. And what was quite incredible about the data that was collected there was that the collection manager, Dave Willard, actually measured the morphology of basically each one of these specimens. So this was a really unparalleled data set. So even with banding data sets, we don't always get all of these measurements, such as beak length. And to have it sort of standardized, measured by one person is truly unique. But this is a record going back 40 years about bird biology from these collisions. And so I was fortunate to get to work with these data and sort of trying to understand, well, what are things that we can learn from from this record? And so with my lab, we actually started analyzing changes in the measurements, and pretty quickly some striking patterns came out. So we analyzed more than 50 species, and in nearly all of them, we found evidence for decline in body size. And so what I show here are plots of 9 species, the sort of most common collision species in the data set. And this shows a decline in their leg length or their tarsus length over 4 decades. And we think this is a good sort of proxy for a decline in their body size. And basically, sort of long story short from this research, we showed that multiple metrics of body size were declining, and whereas the length of the wing in these birds was increasing. Now, why birds are getting longer wings is sort of a mystery that we're still working on. But we think that the long-term trend in body size is actually connected to warming summer temperatures. So there was so much data there that we could see short-term fluctuations in body size just from those Chicago birds. And we were able to correlate that with changes in summer temperature over the years. This was published in 2020, got a lot of media attention, which we used not only to highlight sort of impacts of climate change on birds, but also tried to highlight these collisions and the problem of the collisions in the first place. And then I do want to briefly mention that we also use these records to quantify the amount of or the impact of the light and the lighting practices at McCormick Place. Without going into the details here, we had very strong quantitative evidence from these collisions of the impact of lighting the interior windows on the number of collisions at specific windows over time. And that when lights are off, many fewer collisions than when lights were on. This work was in collaboration with Benjamin Van Doren. So we're actually able to quantitatively model the impact of having McCormick Place fully lit versus more dim on nocturnal collisions from nocturnal bird migration. This did get some attention in the media, even the Chicago Tribune. Of course, it took that sort of massive event almost 2 years later to affect the kind of change that was needed. And so this is a case where it's great to see a reduction in collisions from the treatments to those windows. So I'll just wrap up here by saying that I think there's great opportunities here. So if you're working with a collision monitoring group and you're not already partnering with a museum, this is a great way to kind of make sure that your efforts are also leaving scientific record for posterity. Museums may also be able to help you with the permits, which are required for salvaging these specimens. There are some challenges. Museums, as our collision groups, are underfunded, understaffed. This kind of specimen preparation takes quite a lot of prep time and skill, and not all cities or locations are going to have an active collection. So I would just recommend that if you're not already doing this, try to reach out to your local natural history collection. Of course, wildlife rehabbers should be brought into this pipeline for stun birds, and how that works will really depend on your location. And then museums can advise on best practices here, which usually involves date, location, information for the bird getting frozen as quickly as possible. Don't contribute dead birds to museums without talking to them first, though. So it's really important to have good communication. And then you may also be able to volunteer to help prepare those specimens and actually sort of have them contribute to science and posterity, which I think is a rewarding way of sort of making something good out of this mortality. And of course, our shared goal is to minimize the amount of data. So even though I've sort of benefited scientifically from analyzing the data at McCormick Place, it's gratifying to see that now actually we have very little data coming from McCormick Place. So I'll leave there, and hopefully we can pick this up in the chat.